Alright, these are the notes we're going to take over Unit 10, Day 3, Permutations and Combinations. I'm going to give you a chance to follow along with what I show you in the video, but then I also want you at the appropriate times to pause the video and try some problems on your own. If you have any further questions, you can ask me when we're in class together again. Okay, the probability that we've been discussing in class so far and that you discussed in other classes really is just what we call simple probability, the probability of one event happening when that event really isn't connected or dependent upon any other events. But we have some more complicated probabilities that we can talk about when we have events that are related or connected in different ways. So we're going to start talking about that. Okay, so in this first part, if a decision, we're just going to label it M, so if one specific decision can be made, we'll just use M ways, so this just represents a number, so any number of ways, and another decision can be made, we'll call that N number of ways. The two decisions can be made together by multiplying all the possible of one times all the possible of the other. So we're just going to multiply those. And so what that tells us is an example like this. It's easier to understand when you look at the example. So here's where this comes into play. Let's say we have an ice cream shop that offers a choice of 3 cone sizes, 15 different flavors, and 8 toppings. How many cones are possible if you can only choose one flavor and one topping? So this is using what we call the fundamental counting principle to talk about all the combinations of these. Okay, we're just going to take the number of each category, so this decision has 3 possibilities, times the number in this category, this decision has 15 possibilities, and then the final category that decision has 8 possibilities, and if we multiply all those together, we get a total of 360 different combinations. Okay? And so I want you to try and work on these on your own. If you want to pause the video now, you can, or we can move on to the next topic and you can go back and try these on your own. But at the end of the video, I will show you the answers for all the rest of these that you should get. Okay, so we're going to take a look at another key idea that's going to be very important to us, and that's called factorials. Okay, factorials. Remember, factors, the key word here is factor, are things that are multiplied together. But this concept of factorial, where we use n to represent any number, and then we put an exclamation point after it, is a mathematical concept illustrated here. And it says that the product of all natural numbers, remember those are the counting numbers, from whatever number we're using down to 1, okay, is what we call factorial. Product means we're going to multiply. So here's our example. If I said 9 factorial, that means I'm going to multiply all the numbers from 9 in consecutive order down to 1. Okay, when we multiply all those out, you can use your calculator for this, but when we multiply all these numbers, we get, in this case, 362,800. All right? So in all these different examples, okay, when I multiply them out, you can just do it in the calculator. 12 times 11 times 10 times 9, so on and so forth, down to 1. Okay? We get these answers. Okay, 12 factorial is 479,1,600. Sorry if I read that wrong. 8 factorial is 40,320. Okay, 17 factorial over 11 factorial. We're just going to do these separately and divide them out. The answer there is 8,910,720,000. And then 0 factorial, we've got to be careful with this. Okay, 0 is not a natural number. Okay, so that means I'm not going to have any numbers that I start multiplying down to 1 except the number 1. Since we're talking about a list of factors, when we're multiplying things together, there's always a factor of 1. So 0 factorial is 1. Okay, now I'm going to show you how to do factorial in the calculator the shortest possible way. Okay. Now, if I were to want to do this in the calculator, I'm going to go back to the example we had where we were doing 9 factorial, the very first factorial problem we did. Okay, I would enter the calculator like this. I'm going to enter the number I want, 9, and then I'm going to go to my math menu. If you see the button on your calculator that says math, click that. And we are wanting to use a probability calculation. And so that is under this side of the menu where it says PRB. So I'm going to scroll over to that list, and you'll notice the exclamation point right here, option 4. That is our factorial. So now I can either scroll down to 4 and hit enter, or I can just type the 4 and it'll automatically do it. And so this is the calculator's way of showing you 9 factorial. And if we hit enter now, it gives us that answer. It does all of that for us rather than having to list it out separately like this. Okay, instead of having to list all these out and scroll all the way through, we're going to get the same answer. Okay, and I do notice that earlier in the notes I made a mistake. It should be 362,880, not just 800. I'm sorry about that. All right, but we do get that when we use factorial. So once again, we type in our number. Okay, let's do the next one you had, 12 factorial, 12. And then we go to the math menu and scroll over to probability. And we want option 4. And that'll give us 12 factorial, which is 479,001,600. Okay, you can see where I've fixed this error, so it's correct now. Okay, and so we can use factorial a lot of ways. Now, if I were to do 0 factorial, once again, remember that is always 1. All right, so we're going to talk first about what we call permutations. Okay, a permutation is an arrangement or lineup of objects in which order matters. So when we're talking about possible combinations, when order does matter, the order of your choices does matter. Okay, we call that a permutation, and there's a formula for that. And we use this representation: little n, big capital P. This is like a subscript notation. It's a little letter n, and then a little r. Okay, where n is the number of total number of objects available, and r is the number of objects to use for that arrangement. Okay, we find that by comparing as a ratio the n factorial, so our possible combinations for n, over the difference of n and r, all factorial. Notice the factorial is outside the parentheses. So we're going to practice this before we get going too far, and it'll make a lot more sense. All right, so all we're going to do is do the n factorial divided by the difference of n and r factorial. And I'll explain what these things mean with the examples that we do. Okay, but here's an important shortcut for you to remember. When n and r are the same number, okay, when these two are exactly the same, the shortcut for this is just n factorial. And I'll explain that, because if n and r are the same thing, n minus n would be 0. 0 factorial is 1. Anything over 1 is just the top number, and so we can just cancel out the bottom part when these are the same. Okay, so we're going to try this example. It says, how many ways can you arrange the letters in the word dinosaur? Well, there are 1, 2, 3, 4, 5, 6, 7, 8 distinct letters, meaning different letters, in the word dinosaur. So that is a permutation because the order matters. And so we would write this as 8 permutation 8. Since these are the same, it's really just that number factorial. Okay? I'm going to show you where we got that. 8 factorial over 8 minus 8 factorial. 8 minus 8 is 0. So 0 factorial is that over 1. All right? So we can bypass all of that and just do 8 factorial. When you plug that into your calculator, either doing the long way, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, or using the factorial method in the graphing calculator, we get 40,320. So there are 40,320 combinations of the letters dinosaur. Okay, now I'm going to let you try that again on the next example. Okay, but I will get you started on this. We're talking about 7 students competing in a geography bee. How many ways can they finish in first, second, and third place? All right, so we're talking about all the possible results of these 7 students, 3 of which getting first, second, and third place. We don't have to list out all our combinations. We know that the total number of objects available in this case are the 7 contestants. This is a permutation because the order matters. And there are 3 that will finish each time. Okay, that's the number of objects to use for the arrangement out of each 7. And so remember, we're going to put the 7 factorial on top. And then we're going to do the difference of these 2 numbers, 7 minus 3 factorial on bottom. Okay, so that would be 7 factorial over 4 factorial. Okay, when you list that out, 7 times 6 times 3, 5 times 4 times 3 times 2 times 1. All over just 4 times 3 times 2 times 1. I want you to notice this sequence of factors repeats on the bottom, so we can just cancel those out and make it a little bit easier. In this case, it's only 7 times 6 times 5 that we need for our answer, which is 210. Okay, so permutations are arrangements or lineups of possible combinations where the order does matter. So let's turn the page. There's a whole set of 3 more examples here that I'm not going to take time in the video to show you, but I will show you the answers to those at the end of the video. All right, but we can also talk about permutations with replacement, with repetition, All right, we have letters that repeat in this case. So I want to do one of these examples. So how many different 10-letter arrangements are possible using the letters in this word? Okay, well, we have 10 letters, but there are 2 that are a repeat. And so it's like we're factoring out the repeats. So that's just 10 factorial over 2 factorial, because we're going to take out the common ones since those are really the same letter. Okay, in that case, that would be 1,814,400. And I'm not just doing these in my head. I've done these in the calculator, and so that's how I know I get these answers. Okay, remember, you can use a factorial button on your calculator, or you can write these out the long way. Okay, and then we want to talk about what combinations are, and that's the next part of this. Now, a group of objects in which order doesn't matter are called combinations. And we use this notation, little n, capital C, little r. Same kind of deal, but C for combination, where n is the total number of objects available, r is the number of objects to use for the arrangement. That formula is a little more complex. We still start with our n factorial, number of combinations total factorial, but now we're going to do r factorial times the difference of n minus r factorial. Okay? And again, another important shortcut is that if I have the same total number of objects available as the number of objects to use for the arrangement, that combination is always equal to 1 because everything cancels out. All right? All right, so let's try example 12. Natalie has 16 close friends. How many ways can she choose 5 to be the bridesmaids in her wedding? Well, this is a combination where the order doesn't matter. We're just picking any 5 at a time. So we're going to have 16 combination of 5. In that case, we're going to do 16 factorial over 5 factorial times the difference of 16 and 5 factorial, which in this case is 16 factorial over 5 factorial times 16 minus 5 is 11. Okay? And when we do that, when we do the calculations in our calculator, and you could put all this in at once if you wanted, we get 4,368 possible combinations. So there's more of these, and actually the answer key will be provided by the sub.